In 751, they want to know how would you prepare the following substance by a precipitation reaction. What they're really asking you is which one of these subreactions are not possible, or which one of these subreactions doesn't yield a precipitate. And here's the little game you play. If we just take a look at this first one here, what you notice is aluminum nitrate. Good, that's soluble. Here's where the problem is. Magnesium hydroxide is actually insoluble. That should be a solid, so you can't prepare aluminum hydroxide with it. The next one we look at, well, all chlorides are soluble, check. All sodiums are soluble, check. So when we mix them, aluminum hydroxide is going to precipitate out, and that will stay aqueous. Here we're struck with the opposite problem once again. This is insoluble. Most hydroxides are insoluble, so that one's out. This last one's the one that I really consider kind of a dirty pool, because this is one they don't really give you a guideline for. But it goes like this. You've never seen this thing. You've never seen, that would probably be silicate, let alone aluminum silicate. However, we can tell from our subscripts that this probably has a -2 charge. And remember, the higher the charge, the less likely the compound is to be soluble. So my guess is that aluminum silicate is actually a solid. And as a matter of fact, I believe if you Google it, you'll discover that that's actually a mineral, and I forget what mineral it's called. It's really shiny and silver and kind of flakes. Shoot, I used to have a lot of it as a kid. But that's going to be a solid, so you're not going to be able to form a precipitate with that reaction. So that one's out, and that's sort of your thought process. We go to part B and just continue the thought process a little further, and I'll leave C for you. But if we continue this thought process further, let's see. We're wanting to precipitate out iron sulfide. That's soluble. That's soluble. Hey, we hit it correct on the first mark. Down here, most sulfides are insoluble. So that's out. That's actually going to be a solid of its own. Our next one actually really has two problems. Not only is that likely to be a solid, but most carbonates are also insoluble. So that right there is also going to be insoluble. So we know that that equation's not a valuable, not a viable option there at all. We come and look at the next one. We've got phosphates, and phosphates are insoluble as well. So once again, we're out because that's going to be a solid. So once again, our only viable option that's correctly written is the first one. What you're really doing here is proofreading reactions.